To answer this question, let's try drawing a diagram of the forces that are acting on you. So if you're standing on the scale in the elevator, there's going to be two forces acting on your body. So if we draw you as a dot and then draw the forces that are acting on you, there will be two forces. Gravity, of course, will be pulling downward. So that's your weight. And then since you're standing on the scale will be exerting an upward normal force. So those are the two forces that are acting on you. According to Newton's second law, we can sum those forces that are in the y direction and set them equal to your mass times your acceleration. So if we do that, the sum of the forces in the y direction is going to be, well, there's your upward normal force, and then gravity is acting in the minus direction, so minus mg, and then that's going to be equal to your mass times your acceleration in the y direction. Now the problem is telling us that the elevator is accelerating downward, bringing you with it, with an acceleration of 1 meter per second squared. So let's try putting that into our equation for the sum of the forces. So the normal force minus mg is equal to your mass, and then the acceleration is 1 meter per second squared, and it's in the downward direction, so that means that this acceleration is going to be negative since it's in the minus y direction. So what does this mean as far as the reading on the scale? What is the scale actually reading? Now you might think that the scale is measuring your weight, but in this case it really isn't. The only thing the scale knows is how hard your feet are pressing against it, which is equivalent to how hard it has to press back to keep you from falling through the floor or through the scale. So the scale is really measuring the normal force. The scale knows how hard it needs to press against your feet in order to support how hard you're pressing down on it. So the scale is actually measuring the normal force. So if we solve this expression for the normal force, you can see that the normal force that the scale has to supply and that the scale is actually measuring is equal to your mass times minus 1 meter per second squared for your acceleration, and then we can add the weight to both sides plus mg. So you can see that the scale doesn't have to quite support your weight. There's your weight, but we're subtracting off your mass times the acceleration. So the scale doesn't need to push as hard to support you. So the reading on the scale will be a little bit less than your actual weight.